All right, hello. I'm going to talk about logistic regression a little bit. Okay. To follow along with this, you're going to need tidyverse, modelr, and ggally all loaded up. And then we're going to be using a data set called grad school admissions.csv. As you can see up here, we are in the data course R project, so the main one. So there's my relative file path. Alright, take a look at that, grad school admissions. Let me click on DAT here. There we go. Alright, so this is a data set, real data, decent size, and we have whether somebody was admitted, their GRE score, GPA, and the rank of their undergraduate institution, one being top ranked, four being low ranked. Okay, so this data set doesn't lend itself to normal modeling because what we really care about is whether or not you were admitted to grad school, and that's 1 and 0, false, true. Okay, so the sorts of predictions we make, a standard linear model regression isn't going to be useful for us at all. If we take a look at this, run ggpairs from the ggally package, we take a look at this. So here's a bunch of zeros and ones for admit. That makes sense. Okay. Then we see GPA versus GRE. It looks like a little correlation there. And then rank, those are 1, 2, 3, 4. Alright, so nobody is at an institution ranked 1.5. So let's see here. First thing I want to do is basically build a model. I'm going to look at names of DAT, so I have those handy, so I spell things correctly. I'm going to say mod 1 is GLM, linear model, and the formula is admit as a function of GRE plus GPA plus rank. Now rank, let's see here. Yeah, it's listed as an integer, but really that's a factor, and it would be an ordered factor. So I might want to clean up this data a little bit first. For example, I don't like 1 and 0. I want true false in there. Okay, so just because I like that. So dat where dat admit equals 0. Whoops. Dat admit where dat admit is equal to 0. Okay, I'm going to send false to that. Copy this, paste it down there, and where it's 1, I'm going to put true. So now I look at that, and it didn't freaking work. Why didn't that work? Well, zeros and ones are what they are. So let's try this. Dat admit, okay, ones and zeros, as logical, dat admit, there's my true and false. So dat admit is as logical dat admit. Doop, doop, doop. Okay, yeah, up here, logical, we got a bunch of falses and trues. Alright, GRE and GPA, those are numeric, that's cool. But what about rank? I want that to be a factor, essentially. So dat rank is factor dat rank. Cool. Now, there's our formula. Our data in our model is dat. Done. Summary. that model. All right, take a look at this. Okay, so we see GRE, there's our estimate. GPA, there's our estimate. Those are both significant. And then we've got rank 2, 3, 4. Now remember, since these are a factor, it takes the first one that it found, in this case 1, and uses that as the baseline and tests these. So 2 is different than 1, 3 is different than 1, 4 is different than 1. Alright. But these estimates don't really make sense because we don't have a nice linear relationship, because we're trying to split this into two things, predicting whether something's going to be true or false. So what I need to do in here is add one more thing. This is what makes it the logistic regression. Family equals binomial. Okay. So you can see that our estimates have changed. Right. What they're actually showing you right now is log odds. We don't really enjoy that. If you're in the gambling market, sure, but let's see what they look like. So let's add predictions. Add predictions. Our data is DAT. Our model is mod 1. And then type equals response. This means that we want our prediction values to be in the same scale as our response variable. In this case, that makes it probability. Alright, so there's our crazy data frame. We've got admit, false, GRE 380, GPA 3.61 from a rank 3 school. The odds, the probability of that individual given these three values, probability of them getting into grad school is 17%. And you see they didn't make it. Okay, I'm going to save this as DAT2. That's our data frame with the predictions, and then I'm going to take a look at a plot there. So I'm going to plot DAT2. My aesthetics, x equals, let's go with GPA, y equals pred, and then plus geom, let's just do a point. Okay, so over here we've got GPA. As it goes up, to me it looks like the odds, or the probability of getting into grad school goes up as well. That makes some sense. I'm going to add something else here though. Color equals, what's the name of it? Rank, I believe. Rank. Aha, okay. So if you're at a tier 1 undergraduate institution, say you went to Harvard, your odds are already better, no matter what your GPA is, than somebody at a tier 2, 3, or 4 institution. I keep saying odds. What I'm actually meaning is the probability. Okay. So let's copy this whole graph and do it again, except on the x-axis I'm not going to do GPA, I'm going to do GRE, the graduate record examination test to get into grad school. Let's see how that compares. Okay, so same pattern. The higher your GRE score, the higher the percentage of people, or likelihood that you'll get into grad school. Okay. So if I was to look at this here, and instead of doing geom point, do geom smooth, method equals LM. Yeah, let's leave it there. Alright, so these are predicted probabilities of getting in. This is not reality. Okay, so there's maybe somebody over there who did get into grad school even with a crappy GPA, all right? But this is what our data is telling us the likelihood is of a person getting into grad school given a certain GPA, GRE, and undergraduate institution rank. All right, so the keys here for doing a logistic regression is it's for when your dependent variable is true false. Okay, you need to use GLM, and you need to say family equals binomial. All right, and finally, when you go to add predictions, you have to say type equals response for it to make any sort of sense. Okay. All right, any questions on that, throw them up on Slack.